In this podcast, we're going to look at how we name acids. So first off, you need to know what an acid is. For right now, we're just going to say that acids are ionic compounds that contain a hydrogen and then a negative ion or an anion. So what you really want to look for here to identify an acid is you want to look for these H's in front. See how every one of them has an H in front? So for our purposes, for right now, until we get to our acids unit, you want to look for an H in front, and that's how you'll know it's an acid. All right, there are two kinds of acids. There are binary acids, and there are tertiary or ternary acids. Binary acids just have two elements, okay? So hydrogen and one other element off the periodic table, okay? So they don't have any oxygens in them. They have no polyatomics. All right. Ternary acids always contain oxygen. They always have 3 elements or more in them. Again, you still see the hydrogen in front, but now there's a polyatomic ion that is attached to the hydrogen. All right, so how do we name these? Well, we're going to look at naming binary acids first. So for binary acids, you know that what you want to do is you want to put a prefix of hydro in front of the name of the anion. And then you're going to put the name of the anion and change the ending to ic. Now let's look at some examples of naming binary acids. All right, so here you see we have 3 different binary acids. All right, so we know that one of our naming rules was we always write hydro in the front. So hydro. And then Cl is chlorine. So I'm going to put chlor. And then I'm going to change the ending to ic. So hydrochloric acid. You always throw acid on the end, okay? The next one, again, it's binary, so we're going to put the hydro. This time we have F, which is fluorine. So we're going to do fluor, and then instead of ene, it's going to be ic acid. And lastly, we have H2S. So again, it's binary, so you want to do hydro. And then S is sulfur, so we're going to do sulf. And then instead of sulfur, it ends up being sulfuric. Okay, so this one's slightly different, but you still got to have the ic on the end. Acid, so hydrosulfuric acid. Okay, now to name tertiary acids, you have to look at the name of the polyatomic ion or anion that is attached to it. If it ends in an 8, if your polyatomic ion ends in 8, you're going to change the ending of it to ic. If it ends in ite, you're going to change the ending to us. Okay? So some people like to run all this together to try to help them remember it. So 8, ic, ite, us. I like to think of it as, you know, if I ate something gross, I'd say ick, right? Ate something, ick. And then if I'm ite, that's us, right? I, us, okay? All right, so here's some examples of that. So we have 3 ternary acids. Again, you see you have at least 3 capital letters, and they all have a polyatomic associated with them. Okay, so this one, ClO2, you need to figure out the name of that. So that is actually chlorite, and ite goes to us. So it's going to be chlor us acid. So chlorous acid. Okay, this one, our polyatomic is SO4. SO4 is sulfate. 8 goes to ic. So it would be sulfuric acid. All right, now this next one is sort of unique, which is one reason that I put it on the podcast. So if we look at the name of this, CN, you get cyanide, right? So cyanide ends in IDE, so it doesn't end with ate or ite. So this one is definitely an exception to our ternary acid rule, which is one reason I wanted to bring it up. So if you have a ternary acid whose polyatomic ends in "ide," you have to use binary rules. So binary rules say that we would put hydro and then the root, so cyan, and then change the ending to ic, acid. This is a very special case though, so I just want you guys to know and be aware of that, okay? All right, next we need to know how to determine the formula of an acid. All right, so what you're going to do here is you want to look at the name of the acid, and by looking at the name of the acid, you have to determine what is bonded to H. So if you see hydro in front, you obviously know it's just going to be hydrogen and one other element, unless it's like the special polyatomic ides, right? Which is a rare thing. If it's got an ic or an us on it and no hydro, then you know that it's going to have a polyatomic on it. And looking at it, seeing if it was ic or us should be able to tell you if the original polyatomic was ate or ite. Okay, so anyways, once you figure out what that anion is that is attached to H, you're going to use your charges and you're going to swap and drop to get the formula, just like we did on ionic compounds. So here's some examples. So we have nitrous acid. So I don't have a hydro in front, which tells me that it's going to be a polyatomic. It says us, and if you remember, us came from ite. So I'm looking at hydrogen with the nitrite ion. Okay, so I got H, and H is a 1+ charge. And then nitrite is NO2, 1-. So when you swap and drop that, you get HNO2. So that's the formula for nitrous acid. Okay, the next one wants the formula for hydroiodic. Okay, so we get this hydro in front, which tells us that we have just a single element, most likely, right? So we got H, and then the back of it is iodic. Okay, so that is the stem for iodine, which is I. And then you're going to put your charges with your H and your I, swap and drop, and there's your formula. So basically, hydroiodic acid is just high. Okay, and lastly, the formula for phosphoric acid. Okay, so we see there's no hydro, so this means we're dealing with a polyatomic. It ends in ic. Ic came from 8. So this is phosphate. So if you look up the phosphate ion, it's PO4, 3-, and it's an acid, so we know it's got to have that H on the front. So we swap and drop our charges, and we get the formula for phosphoric acid as H3PO4.